Welcome to the first session of the Tungsten Cluster Masterclass series, where we take a top-level view of what a tungsten cluster is. My name is Chris Parker, VP of Customer Success here at Continuant. In this session, we'll review the benefits of tungsten cluster and then dig down into the three components that make a cluster work. We will then take a look at the main topologies available and finally summarize how failover and rolling maintenance works. First, let's take a look at the key benefits. Tungsten Cluster is designed for continuous MySQL operations, offering a complete HA and DR solution that works right out of the box. The components of the cluster, which we will cover later in this presentation, work in harmony, providing automatic failover for maximum availability, reducing MySQL recovery time from hours to seconds. We also provide a graphical dashboard to view and manage your clusters. We have a separate masterclass for the dashboard, and we also cover the introduction to this in a later training session in the cluster series. With the ability to handle seamless primary host switches, we enable zero-downtime maintenance. Our complex topologies allow for geoscaling, enabling you to distribute your data, be it regionally, nationally, or even globally. Our platform-agnostic approach allows you to operate the cluster from wherever fits your business needs best, whether that is in the cloud or on your own hardware, and what's more, you can connect all of these clusters forming hybrid or multi-cloud topologies. The connector provides the intelligent proxy layer, enabling your applications to connect with ease to the cluster and to scale reads across replicas. We support all flavors of MySQL, be it Community Edition, Enterprise Edition, Percona, and MariaDB. With support for all versions from 5.x up to and including 8 and 8.4. Older Tungsten releases may not support the newer MySQL releases, so do check the compatibility matrix in our documentation pages to ensure you're running certified versions. Now let's take a look under the hood at what makes a cluster work. So the Tungsten cluster comprises of three Java components: the connector, the manager, and the replicator. Let's look at each of those in turn. First, the connector or proxy. This acts as the main path into the cluster for your applications, routing the requests to the appropriate node within the cluster, with intelligent read-write load balancing controlled by various modes and methods available. There are many different ways to configure the connector, each with varying levels of complexity, from the most simple and default mode, which we call bridge mode, to the most complex and intelligent proxy-based smart scale. There are specific sessions in this training that cover all of these in more depth, so I won't go into great detail here on how each of these worked. The connectors are fully cluster aware, ensuring your application requests are directed to the correct node. Typically, in a cluster, you would have at least two connector nodes to ensure availability, and ideally they should not be located on the same node as the database. And we cover this in more detail later in the course. There are also some links here to some blogs which may provide some additional reading. The manager is a rules-based process with one manager existing on each database node. They are responsible for all the communication between all the components and ensuring the cluster is healthy. Through its rule-based system, the managers are able to react to a vast range of situations and able to act accordingly, from a simple restart of a process if it stops to controlling a failover of the primary node. Like any clustering technology, quorum is the key, and this ensures that the managers are able to vote together on decisions during failover. For this reason, you must have an odd number of nodes within a cluster, or more specifically, an odd number of managers. You'll notice that I highlight this a lot through the training, as it is essential to ensure a healthy operational cluster. The replicator, as the name suggests, replicates the data between nodes asynchronously. Each replicator is able to operate either as an extractor or an applier, and this is controlled by the managers informing the replicator which role to take on at any point in time. Replication is transactionally complete, and by that I mean that we will only replicate a transaction when the entire transaction is complete and committed to the binary logs. The replicator converts this binary log information from MySQL into THL, or the transaction history log, which is our own native format, and it's pretty much like a binary log, but in a format that we have control over. The replicator, they have multiple stages for best performance, and with advanced filtering available as well. Although typically within a cluster you wouldn't necessarily use filtering, as you would want to ensure the nodes are consistent. For that reason, I don't go into detail on filtering in this clustering masterclass. However, if this is a topic of interest, you can explore it more in the Replicator masterclasses. And this diagram just highlights the process of the replicator. So here we show the replicator on the left in the extract role, reading and processing the binary logs and creating THL. At this point, the role of the extractor is pretty much complete. The replicators in the apply role are then responsible for pulling that THL across the network, and from there they then extract and reapply via JDBC into the target node. Let's now review the different topologies available. First, the simplest topology and the foundation for all of the others. The standalone cluster provides high availability with automated database management. This topology would consist of a single primary node and a minimum of 2 replicas, ensuring the total number of nodes is at least 3 and an odd number. And this comes down to quorum, which I mentioned in the earlier slide. Although this diagram only shows 1 connector, you would need to have at least 2 for availability. The cluster would typically reside in a single data center or a single cloud region. It's not designed for DR since the nodes cannot be geo-distributed. The Composite Active-Passive cluster builds on the foundation of the standalone cluster of HA and adds in the benefit of DR or disaster recovery. Here you would have at least 2 clusters consisting of the same minimum requirements of 3 nodes per cluster. One cluster would be configured as the active cluster, the other cluster or clusters would be passive. Within the active cluster, you would have the primary node that takes all of the write traffic. Replication then flows down the local replicas and across to the other clusters via the relay node, which will then distribute down to its local replicas. The connectors will ensure all the write traffic is sent to the active cluster accordingly, regardless of which cluster the connector is primarily associated with. Additionally, all reads can then be distributed across any node in any cluster, not only providing that HADR capability, but also expanding the availability of your data to applications and clients that could also be geolocated, putting the data closer to your customer. Whilst failover between nodes within a cluster is automatic, should the active cluster fail completely, then an operator would manually promote one of the passive clusters to be the new active cluster. The relay node in that cluster would then take on the role of the primary node. This process is manual by design to ensure that failovers do not happen under false conditions, especially important for geo-distributed clusters where network latency may be high. Our Composite Active-Active cluster is our most complex topology that requires a high level of proficiency to manage, both from a Tungsten aspect, but also internally with your own applications. The Active-Active cluster, like the Active-Passive, will consist of at least 2 clusters with at least 3 nodes per cluster. In this topology, all clusters are active, each with their own primary node accepting writes from the local connectors. The cross-site bidirectional replication then ensures traffic from remote clusters is also replicated. This complex topology requires applications to be able to act accordingly in an active-active environment to ensure data conflicts do not happen. Tungsten Cluster does not have automated conflict resolution built in. This is due to the high complexity of handling such conflicts, which for every customer and every application may have differing rules to handle. We do, however, provide best practices. We cover this in more detail in our advanced training sessions later in this series. Dynamic Active-Active offers the benefits of the Active-Active cluster with the simplicity of the Active-Passive cluster. Again, you would have a minimum of 2 clusters with 3 nodes per cluster, and like the Active-Active cluster, all clusters are active. However, the difference here is that from an application perspective, the clusters behave like Active-Passive, with the writes being directed only to one primary node. Unlike Active-Passive, where the failover between clusters needs to be a manual process, in Dynamic Active-Active, this failover is automatic, but triggered and handled at the connector layer by use of affinity. During installation, a nominated cluster will be assigned the affinity for all connectors. If this cluster is then lost, the connectors will reroute the write traffic to one of the other clusters, which again is also configurable. This topology is best suited for customers that require the ability to not have to failover between clusters, but also cannot handle potential data conflicts and need a single point to write. Dynamic Active-Active was introduced in version 7 of Tungsten Clustering. Our final topology is Dynamic Datasource Groups, introduced in version 7.1 of Tungsten Clustering. This topology takes the benefit of the composite clusters, such as geo-distribution, but combines them into a single cluster, ensuring you have those DR capabilities, but on a smaller scale without the overheads of needing multiple clusters or the manual failover process of active-passive. Within this topology, you would still have a single primary with multiple replicas, but here nodes can be distributed across regions. Each distinct region would then be grouped together by a Distributed Data Source Group ID or DDG ID. In the diagram here, we show the primary and 2 replicas in one Dynamic Datasource Group and 2 replicas in 2 other separate groups. In this instance, should the primary fail, we would only consider the replicas within the same data source group as a candidate for primary. And only if all of those nodes were unavailable would we promote a node in one of the other data source groups. Now that we understand the topologies, let's take a quick look at how failover works. So here we show a typical 3-node cluster with the application on the left, the connectors in the middle, and the data nodes on the right-hand side. This process is the same regardless of the topology installed. So we lose the primary. The first thing the managers do upon detecting this is to shun the node. This signals to the connectors that this node is no longer available. The connectors will then halt any further incoming connections. Depending on how the connectors are configured, existing connections will either be paused and appear to hang, or they will be disconnected. We cover this in more detail in the connector training sessions. The managers will then vote and elect a replica to be the new primary, using the rules-based system to make the decision based on various factors such as which node is most up to date and which is the quickest to promote. The replicator is promoted to be an extractor and the node is marked as a primary, at which point the connector will start to allow new connections. Resuming the query flow, if the connector was holding existing connections, these would now automatically resume and be connected seamlessly to the new primary. The remaining replica will be configured to now see the newly promoted primary as the source for its replication. When your DBA or system engineers have resolved the issue with the failed primary, the node can be recovered and placed back into the cluster, this time as a replica. We do not automatically switch the roles back when you reintroduce a failed node. Replication is then recovered and we have an operational cluster once more. Zero-Downtime Maintenance is one of the most useful features of the cluster, enables you to make changes node by node without the need to switch your applications off and upset your customers. This is the typical workflow for the rolling maintenance process for upgrading MySQL. First, you would shun a replica node. This marks the replica as isolated within the cluster and connectors will not send traffic to it. It is then safe to stop the Tungsten services if required. Not every type of maintenance will require you to stop the Tungsten services, but upgrading MySQL or performing operating system changes, then it would be recommended. Then you can perform your database upgrade and finally restart Tungsten services and return the node to the cluster. Once replication is caught up, you can then repeat the process on all remaining replicas, one at a time. Finally, you would then issue a switch, which would promote one of those new replicas to be the new primary and change the primary to be a replica. You can then repeat this maintenance process on this last node before returning it back to the cluster. In summary, this is what we have covered at a rather high level today. We've reviewed the key benefits offered by continuous tungsten clustering. We've examined the cluster architecture, so the components, the manager, the connector, and the replicator. We've looked at the various topologies. We've had a brief look at how automatic failover works, and we've looked into the concepts of a rolling maintenance procedure. This session was designed to be an introductory level, and all of the concepts that we've talked about here are explored in a lot more detail in further training sessions as you progress through the clustering series. So I hope you found this session informative, and I look forward to welcoming you on to another session soon. Thank you and goodbye.